For your project, you are going to calculate a Pearson's correlation coefficient. It is a number that tells us whether data on two different variables are related. So my two different variables, my x value are cups of coffee consumed, and my y values are number of hours slept per night. So for individual number one, they drank 4 cups of coffee a day and they sleep 8 hours per night. Individual number two, 5 cups of coffee a day, they sleep 7 hours per night, so on and so forth. I have 10 data sets here. I am going to enter them all in. I should have at least 10. And then I'm going to simply hit calculate R. It is going to bring up my value of R. Once you get that, you're going to copy and paste it. Okay, so my value of R is 0.17. You will use this as a guide to determine whether it is a small correlation, so it means a small relationship, medium relationship, or large relationship. Our Pearson's correlation coefficient will be measured in both negative and positive numbers from 0.0 to either positive 1.0 or negative 1.0. Your positive relationships simply mean as numbers on one variable go up, so do they also on the second variable. Negative relationship means as numbers on one variable go down, numbers on your second variable move in the opposite direction, they're going to go up. So for positive or negative, if your number is 0.1 to 0.3, you have a small correlation. 0.3 to 0.5, you have a medium correlation. 0.5 to 1.0, you have a large correlation. It is necessary, you must add the negative if you have a negative correlation. So mine was 0.17. I have a small positive correlation. So remember, I have copied this number. I am going to come over here. I want to calculate a p-value from my R-score. A p-value lets us know whether there is a statistical significance in our results. So R-score, copy and paste, and then N. N is your number of data points minus 2. So I collected data from 10 different people. Minus 2, going to hit 8. I'm going to keep my significance level at 0.05. That means that I am okay with taking a 5% chance that results that I obtain are done simply by chance, that I receive them simply by chance, that there's not actually statistical significance, but that I can state with pretty firm resolution or certainty that if I receive significant results, that yes, there is some coffee somehow disrupts, causes a change in sleep. Okay, so 0.05, leave that there. I'm going to hit calculate. In order for my p-value to be significant, it must be smaller than 0.05. My p-value is 0.687. It is much larger than 0.05, and so my results are not statistically significant. So how we would report this, how you're going to report it on your paper. Here's an example. IQ and GPA were found to be moderately positively correlated. R equals 38, R38 equals 0.34, P equals 0.032. So for this one, imagine we've conducted a study of 40 students, remember it's 40 minus 2, that looked at whether IQ scores and GPA are correlated or there's a relationship. We might report the results like this. So R parentheses 38 equals 0.34, that is your R value, comma, P equals 0.032. So mine would look like R8 equals 0.17, that is my R value, and then P equals 0.687. 0.67 or 0.69 if you want to round. I expect to see that in your paper. Also on this right here, I think I forgot to mention, this will automatically make an X value, Y value scatter plot for you. You are welcome to copy and paste this one and insert it in your report. Your other option is to use Excel, or I believe you can do it on Google Sheets and enter the numbers yourself. And really you could just copy and paste this, put it in an Excel worksheet, and it would come up with the same thing. Please reach out if you have any questions. I am available via email. It's ajamison@ferrum.edu.